I will briefly summarize the three gas laws and its graphical representations. The first one, we will begin with Gay-Lussac. In Gay-Lussac law, pressure is directly proportional to temperature. So if you're going to plot a graph with P versus T, P on the y-axis and T on the x-axis, you're going to get a straight line graph like this with a positive gradient. That is because these two variables are directly related or directly proportional. When one of these variables increase, the other variable will also increase. So they have a positive relationship. Okay, they have a positive or direct relationship. So P and T are directly proportional. In Gay-Lussac, the volume of the gas is kept constant. Using equation, we can represent Gay-Lussac law in this manner. P over T is equals to K. K is a constant. When we bring T over, it becomes P equals to KT. Okay, P equals to KT. So when pressure increases, temperature will increase. In Charles' law, volume and temperature are directly proportional. Okay, or V equals to KT. If you're going to plot out this relationship, it's going to be a straight line with a positive gradient, which shows that it is a direct positive relationship. When V increases, T will also increase. They move in the same direction. Okay, when V increases, T will also increase, or when T increases, V will increase. In Charles' law, the pressure of the gas is kept constant or fixed. Moving on, let's look at Boyle's law. Boyle's law is represented by the equation PV equals to K, or P equals to K over V, or P is directly proportional to an inverse of volume. Okay, if you were to plot P versus V, pressure versus V, you'll find that they do not have a positive or direct relationship. When P increases, when P is increased, what happens to the volume? Volume decreases. Vice versa. If you increase volume, pressure drops. So they move in two different directions. These two variables move in opposite directions, so they are not directly proportional. They are inversely proportional. Because they do not move in the same direction. Another way to show Boyle's law is to graph P versus 1 over V. 1 over V is the inverse of volume. When you graph P versus 1 over V, you get a straight line, positive curve like this. Now, why is this different from this? Okay, that is because you are graphing P versus 1 over V and not P versus V. So it's important to know what you are graphing. Okay, what are the variables?